Site Sentinel Nano Configuration. Make sure to remove the protective tab on the battery before configuring the Nano. If the system loses power and the tab is not removed, you will lose your configuration.
This is Tony Roach, the Field Service Representative and Trainer for OPW FMS. I would like to talk to you today about connecting to and configuring a Nano Tank Gauge via the web browser and using your laptop computer. The first thing we need to understand is how to get connected to the Nano with our computer using a crossover cable. In order to do that, we may need to set up a static IP address on our computer as well as the Nano Tank Gauge itself. The way we make that change on our computer is if you go to the bottom right hand corner, you'll have an icon that gets to the Ethernet adapter settings. If you right click on that and select Open Network and Sharing Center, it opens up the configuration screen for your network adapters. If you click on the left side, change adapter settings, and then we're going to select the local area connection. You right click on it and select Properties, and then in the Properties dialog we are looking for the Internet Protocol version 4. If you click on it and select Properties again, in this screen, in this dialog box right here, we decide whether we're going to obtain an IP automatically or use a static. So if we select use the following IP address because we're going to connect using a crossover cable, we would select that and punch in an IP address that is one number off from the IP address of the Nano. The factory default for the Nano is 192.168.1.111, and since our laptop needs to be one off from that, we could set our laptop at 110. Then in our subnet mask, if we would just go ahead and leave that populated at 255.255.255.0, that would be fine. And since we're using a direct connection, you do not need to worry about putting in a default gateway. Now on the unit that we're going to be using today, we have it actually on our network, so I'm not going to make these changes. We have our computer still set to obtain an IP automatically. If you're going to connect to a monitor that is already in a network, in all likelihood you will only need to plug into that network and enter the IP address for the Nano, and it will allow you to get a connection. So we're just going to cancel out here, and the same thing here, but that is where you go to make those changes. Once we have our adapter settings where we need them, we're just going to open a web browser, and I'm just going to open Internet Explorer. And in the address bar, and I caution you to use the address bar and not the search box, we're going to punch in the IP address of our Nano, which for us at this location, it's 10.35.3.202. And once we have our IP address input correctly, it opens up this dialog box for us, and it's asking for username and password. The username and password from the factory for all Nanos is, the username is user, and the password is pass. And we click OK. Once you're actually connected to the Nano itself, on the left side of your screen you will notice the menu buttons that we have available to us. We have our site summary, which is just as the title denotes, it's just a summary of some of the information from the location, the products that we use, installed options that we have on the unit, firmware is where we do complete field upgrades, of course cold start, and if you will recall from looking through your manual, a cold start is what is recommended when you first fire up a unit, and that is so we can clear out any data that may be still in the unit from testing at the factory. We will do that momentarily. We have our preferences button, which are just things to do with the way the system is going to run, as well as our address book and settings for obtaining emails and sending emails and things such as that. Site setup, everything that's set up in the unit and the parameters that are programmed for that. Reconciliation is where we set up how we're going to reconcile the products sold at the dispenser with the product that is left in the tank. Our reports are pretty self-explanatory. Any reports that we would need, we would set up and or retrieve under these buttons. And then we have some diagnostics that we will talk about. But the first place that we want to start, normally we would say we're going to go from top to bottom, and after just a couple of exceptions to that, that's exactly the way that we will run the programming. We will start in our site setup though and run the auto detect. When we get ready to go to site setup, there is one other item that we need to take care of first, and that is all the way down in the Diagnostics tab. In Diagnostics, we have a selection for Barrier Diagnostics. So when you select Barrier Diagnostics, this shows us the status of the barrier, the internal barrier in the Nano, in as far as the power being used on all the channels and the contactors, and whether we have power on the system or not. Now this potentiometer, actually from the factory, this defaults to 27, and one of the things that we have to do before we start programming things that are attached to the barrier is calibrate the barrier. This would also have to be done anytime you did a cold start, because this calibration factor, which is what's on this potentiometer, is cleared with a cold start. Now it's very easy to do this. The first thing that you would do is remove the cover from the monitor after it's installed and has power. Then we need to turn the power off to the monitor and unplug all of the connections going into the barrier board on the right hand side of the unit. And as you can see, we can simply just leave the plug hanging with all the wires and cables connected to it. Then we would power the unit back up, get connected to the unit via our laptop, select Diagnostics, Barrier Diagnostics, and then we would simply click the Calibrate button, and it's automated from that point. And as I said, the potentiometer will default to 27, but after we calibrate, we should end up somewhere in the mid 60s to even lower 70s range. Once that is done, you can simply power the unit back down, reconnect the barrier plug with all the cables attached, and power the unit back up, and then continue on with our site setup. And if we click on Auto Detect, what the system is going to do is it's going to go out and show us everything that's connected to our monitor at the moment. Now, Nano, on the first power up, is going to automatically go out and detect anything that's connected to the internal IS barrier. So what we should see here when we click Auto Detect are the items that we have currently installed. And as you can see on channel 1, I have one probe, and you can tell it's the picture of a probe on the icon. On channel 2, I have a probe and a sensor. That's one of the differences between Integra and Nano, is that Nano will allow a mixed multi-drop. We can put smart sensors and probes on the same channel. We'll discuss that more in depth a little later as well. And then on channel 3, I have an icon that shows sensors, but if we click on that, we can see that we actually have 2 sensors connected on channel 3, and channel 4 is empty at this moment, and that's what it would look like in the field with nothing connected. So once we've gone through our auto detect and we know that we're seeing everything that we have connected, we're ready to move on with actual programming of the gauge itself. The next exception that we want to run is in the Preferences tab, and it's the address book. What we will do here is select the address book, and from here we input anyone who would need to receive an email or an SMS from the Nano gauge in a report, for an inventory report or alarm reports and things like that. If we don't have anyone put in the address book, then of course we can't send any emails out to anyone as well. And as you can see, we have a couple of names in there. It's pretty easy to add another name. You just simply click add and put in a first name. John Smith, that's a real common name, isn't it? And let's say he just works for Anywhere. And then of course his email, whatever it may be. An SMS, if we had an SMS set up, which means we're going to send text messages, you would put the information from that in this field, and then you just simply click apply. And that's all there is to adding someone in the address book. There are some things that we have to set up in just the next few minutes that we're going to require these, which is why it's one of the 2 exceptions to going top to bottom. Once we have our address book set, though, we're going to go back up to Site Summary. And when we click on Site Summary, the first button down is Site Information. And as you can see, we already have some information programmed in here. We have a site name, a site ID, a contact name, address, all the way down to the phone number at the bottom. Pretty cut and dry and easy to understand. You must click apply after you do these things, though. And we've had instances where people have programmed virtually a whole Nano machine and never clicked apply, because you can go right over on the left hand side and click the next field down. But if you did not apply what you did in the first field, it will not be active in the gauge. After we get our site information in, we have the product reference table that comes up. And basically what we have here, as you can see, we can go up to 16, and it is different products that are offered by this location. It may be regular, plus, premium, diesel, kerosene, heating oil, whatever the options may be. But we would need these to complete some of the other setups, so it's actually included in our site summary. As you can see, we have 2 products, regular and diesel. The installed options is for reference. If you look in the installed options, we can see options that are available, and if the check mark is there, that means they are active on the Nano. Firmware is where we would go complete software upgrades or firmware upgrades. If there was something in the installed options that was lacking that we wanted to add, maybe we didn't have ACR and we wanted to add an ACR, this is where we would go and add that. And it's just in firmware. You would be sent a file that you put on a thumb drive and plug it into one of the USB ports on the bottom of the Nano. Browse to that file on that drive, and then just simply click upgrade, and it would move all of that into the unit itself. Cold start, and we talked about cold start a little bit earlier, and the fact that we need to always do a cold start when we first bring a unit up to make sure we have cleared out anything that was in there from the factory. It's pretty easy. You select cold start. At the bottom you select cold start, and if you say OK on factory data reset, it will clear everything out that has been programmed and will take it back to the quote-unquote factory data. Right, I'm not going to do that right now because we do have some things on this unit we want to demonstrate. Backup and restore. Backup and restore is just as the title says. Once we get finished programming everything, it is very important that we complete a backup of that system in case something happens in the future and we would need to clear out some data and then restore it back to the originally programmed setup or something to that effect whenever this backup was taken. So if we did a backup right now, we just simply click backup and say OK, because it asks, do you want to backup, save the existing configuration? We say OK. And what it does is it puts a copy of all of the things that you have programmed on the SD card. Now, if you look in your manual, there are instructions on how to take that backed up data off of that SD card and put it onto your computer. And then, of course, restore is just the opposite. You click restore, and it will go out and find that file on the SD card and use it to restore the configuration on the unit. The next tab down is preferences, and in preferences, as we mentioned, these are the way that you want the system to work. Of course, this is where that address book is, where we were. The next thing down is our port settings. Now, port settings is where we set up any remote communication that we want to have with the Nano. And we have three services that are available. We have a POS interface, a pump interface, and a second POS interface if we would need that. It's pretty self-explanatory to set these up once you understand where and how the connections are made. So for instance, let's say we had a POS that we wanted to connect to the Nano. We would simply select a POS interface because that's the connection we want to make. Then how are we going to connect that interface to the Nano? Well, in this instance, let's just say we're going to go in through a LAN or WAN connection. We simply select both of those items and click Map. Now, once we click Map, we get another dialog box, and the first question it asks is protocol, which means what language are we going to talk to the gauge with. And we can emulate a whole bunch of different languages. These need to be selected for what your POS is expecting to hear and to speak in. We have TLS 350, SCP 350, the TLS 250 is Smiths, PV4s, Reliance, the Eco 350s. We have plethora of selections available for us. And then we would simply tell it which port we were connecting to for that protocol. We would normally leave the perimeters box empty. If something would need to be in there, that would be very site and POS specific, and they would have information on that. And then we simply click apply. And the Nano is now expecting a POS to be plugged into the LAN that is going to communicate on port 10,001 using whatever command structure we told it to. And you can see it has a green check mark and says it is configured. We could do the same thing for pump interface or a second POS interface on the same unit. As a matter of fact, we could take those in the same LAN port. System preferences. When we look at preferences, it is just that how do we want some of the system-wide things to actually function. The buzzer duration, pretty important. We would want to check normally until event ends or it is acknowledged. We don't want the buzzer to just sit out there and keep beeping even when the overfill is gone or the alarm has been cleared in a sensor or a low product or something to that effect. So if we select until event ends or is acknowledged, the alarm will silence once the event ends as well as being acknowledged. Most places, depending on where you place the monitor itself, you may want to do an auto silence after a fixed period. If the monitor is hanging beside the cashier's head, they probably don't want it to scream just endlessly, especially if they're busy. So you might want to put a timer in here. We've actually set this one up for 1 second, so it would just beep for 1 second and shut off all by itself. Internal outputs. Turn off the position only at the end of the event. Once again, this is something that we need to consider when we are depending on what is connected. For instance, if we have an overfill alarm connected to one of the internal outputs, if we check this box, once that relay closes, it will stay closed until the event is over, or in other words, until the overfill is not active. One of the things that this enables us to do is to sound multiple alarms. For instance, if you have an overfill on tank number 1 that sounds the alarm, but once we acknowledge the event, our relay opens back up. Then while that overfill is still active on tank 1, if you have another overfill on tank 2, we will sound another alarm because we would close the relay once again. If we have an output module installed, and if you look in your manuals, you'll note that the OM4 output module is the one thing that we can install on the Nano that speaks over Petronet. And we could have up to 4 of those. And we would just simply tell it which one of the relays was connected and what the action was on it. Output module logic. On the output modules that we may have connected, we want to leave it standard, which means the common and normally open contacts are open all of the time and we close them on an alarm, or do you want to change it to closed under power, which would mean that as long as the power was on to the system, we would have continuity between the common and normally open contacts. This is what we would normally call a fail-safe application, because if you had something being powered off of this normally open connection in a closed under power scenario, if someone turned the power off to the unit, the relay would open. Hence, they could not turn the power off to the unit to bypass any safety features that were there. Moving on down our list under user preferences. In user preferences, this is how the user that is going to be logged in to do programming and things such as that on the monitor are set up as far as the language they want the units they're going to use, how you want it to appear, date and time, and things such as that. This is not the address book. The address book is simply a way for people outside to be notified of something that happens on the monitor, and it has no bearing on whether those people can access the machine or not. This button here that says lock site configuration, that's a very important button to understand. Normally we would never use that. There are some parts of the world where it is required, but when you select lock site configuration, you do just that. It pretty much locks the site up so no one could change any configuration settings at all. And when we say it is locked up, it is locked up. There are no back doors. So you don't want to click this unless you know absolutely that's what you need to do. Under warnings, this is where we set up how the system problems are going to be handled, or such as a printer failure is the first one. If we check the box under Audible, that means we're going to sound the buzzer if the printer fails. Do we want to print on the event start or end? Do we want to close one of the internal outputs when that happens? And do we want any alarm notifications out to an email or SMS, which is texting? So let's just, on a printer fail, let's just say we're going to send an email out to me. Right? So now this, you see how this changed black? That means that if a printer fails, we're going to sound the beeper and we're going to send an email out to Tony Roach, who will be notified that that printer has failed. And as you can see down through the list here, we have several options available to us. The internal input contacts are simply a dry contact that we're looking for a relay or something outside of the Nano to close, and we see that relay close. So looking at contact number 1, if we see that relay close, let's say we're going to print on the beginning of that event, assuming of course we have a printer installed. We're going to print when that event ends, and we're going to send an email out to John Smith. So we may have a generator or something connected and coming in on that, and we can actually have it print when the generator comes on because it closed its contact, print when the generator turns off because it opened its contact, and send an email out to John Smith notifying him that, hey, the generator came on at this site. And as you can see, we have several other alarm conditions available to us. And then, of course, if you do not click apply, none of that takes effect. Email and SMS. When we get to email and SMS setup, this is where we actually set up the email account for the monitor itself. The SMTP server, the sender name, user, and password are all things that will be provided by whoever the SMTP account is. It's the same information that you have to have in order to send an email. The Nano needs input here so that it can send an email. No SMTP server installed means the Nano cannot send an email out. And then, of course, we have the information from whoever an SMS provider may be. And SMS is pretty much texting, and they would once again be the ones that would supply you all of this information. No apply, no work. If we click on the networking button, this is where we can actually go in and see what the IP address is currently for our Nano. We can see the IP address, the subnet mask, the default gateway, and the DNS server that we're coming through. Now Nano defaults to a static IP, and that static IP once again is 192.168.1.111, and that's going to be from the factory. So if you have a location that is going to use DHCP, which means they have a router or a switch that's going to automatically pull its IP address and such, then you would need to go in and change this to DHCP so it would do that. And once again, you have to apply or it doesn't work. Change the password. If we change the password here, what we are changing is the password for remote access with the web browser. You remember when we had the username of user and the password was pass? You can change that here so that the owner or customer could have a little bit more control over who could connect to it remotely via the web browser. Bear in mind, if this password gets changed, someone who is actually programming with the touch screen on the Nano can reset it back to the factory default of PASS, but no one else can, and you will not be able to access remotely if you do not have the correct password. Once we've completed our preference setup, the next thing on the list is site setup. And now this is where we actually start programming things for the monitor. I'm going to elaborate on the ability to install probes and sensors on the same input on the IS barrier of the gauge, which we call mixed multi-drop. According to the field wiring diagram, we see a probe cable and a sensor cable tapping into one Belden cable inside the junction box, and that one cable continues onto the gauge. This allows for considerable less wiring at the site. As an example, you can run one Belden cable out to a regular tank in the tank field and have the probe, STP sump sensor, annular space sensor, and maybe you have a transition sump sensor all connected to the one Belden cable coming into the building. The Nano Gauge has the ability to install up to 4 probes or 12 smart sensors on the same channel. Let's think of that as a point system. Each channel can handle 12 points. A probe is worth 3 points and a sensor is worth 1 point. If you reference the chart that is in the library as well, you get some good examples of how this might work in a mixed multi-drop scenario. Remember, the system can handle a total of 48 points, but an additional limitation to the system is that it may be able to handle a maximum of 12 probes, but we are limited to a total of 24 sensors. We've already completed our auto detect, and if you go look at it again, it will simply show you and remind you of the things that are connected to the unit. Tank configuration. In this screen, this is where we're going to set up everything that is tank related. If you look right now under tank number, I have 2 tanks installed, tank 1 and tank 2. If you want to configure a new tank, you can do that even before we have installed the unit and mounted it to the wall, installed the probes and connected them. All of this programming could be done technically in your office, and then you could go out to a site and simply make the assignments. To add a new tank, you would simply click the box that says configure new tank. It says, hey, no probes are available, and you just say okay, because it will still let you configure the tank. So we're going to configure tank 3. No serial number because we don't have a probe yet, but we can give it a name. And let's call it Premium. It's not in a manifolded group because it's just a standalone tank. The product name, now we would remember when I was talking about we had to add products. Now we're trying to add a tank that doesn't have a product assigned to it, so I don't have a product to put in my premium tank. Right, so we will go back over here to Site Summary and go to Product Reference Table real quick and add Premium. And then we click Apply. And we now have 3 products available. So we go back to our tank configuration again. You see how important it is to do things in the order that has been explained, and it's what is in your manual as well. So now we can do tank number 3 and call it Premium. Product name is Premium, and the tank shape is whatever we want. I'm going to select cylinder with flat ends, and there's no dished end on it. The tank color, and we have several colors available, and this is simply the color that it's going to show on the inventory tab. So let's select that red one right there. Tank diameter, we'll say it's 96 inches, but you would want to get this number off of the last line entry in your tank chart, and it may be 96, it may be 94.25 or something other than that, but that's where you need to get that number. The capacity, let's just say it's 9728. And once again, this capacity number is the last entry in your tank chart that the tank supplier gave you. Safe working capacity automatically fills at 95%, I'm sorry. product offset. The only time we would really need a product offset is if we know for some reason or another that the probe is not sitting on the bottom of the tank. For instance, if you had a striker plate that was holding the probe an inch off of the bottom, we would put in a 1-inch offset, and it would automatically add 1 inch to the height that it was reading on the probe for any height measurements in inventory. So we're going to just assume that we're sitting on the bottom of the tank with this tank. Do we have a water float? Yes or no? If we select enable, that means that we are telling it there is a water float there. And we can input a water offset. Now, the water offset is just like the product offset, in that if for some reason or another the water float itself could not sit on the bottom of the tank. So if we had a tank that had been in the ground for an extended period of time, they have a tendency to develop some sludge in the bottom. And if that sludge was a 1/2 of an inch thick, then that is a 1/2 of an inch that water float could not be sitting on the bottom of the tank. And we would add that as a water offset. Now, liftoff defaults to 0 inches, but what liftoff actually means is how much water would it take to be in the bottom of the tank for the float to actually start moving. And believe it or not, most of the floats in the industry need about 3/4 of an inch before the float itself actually starts moving. So what would happen if we put a 3/4 inch lift off in here? Anytime we read any water, it would automatically add 3/4 of an inch to that level that it was reading, because it knows that it takes that 3/4 of an inch for the float to start moving in the first place. Delivery timer, 10-12 minutes. What this is the amount of time it should take for a standard load to be delivered, and we'll keep the delivery active for that amount of time before we print a report. It's mostly just to prevent getting multiple delivery reports. TEC is not used in this country. It's a Russian perimeter that was put in there. It stands for thermal evaporation coefficient. And the only place that I'm aware of that uses it is Russia. Always show net volume, yes or no. This just tells it whether or not we want to display the temperature compensated volume of the tank, and that is something that you could discuss with your customers to whether you want them to have that information or not. Density API is a number that has to do with the actual density as compared to water of the product that's being measured. It's a very important number, especially for tank testing. The most accurate place to obtain this number is going to be on a delivery report for the site, because they can fluctuate from company to company as well as from regions of the country to other regions of the country. This number has to do with how much change is going to happen in the product at what temperature, and the standard for the temperature is 60 degrees Fahrenheit. Acr configuration, which basically means do you have reconciliation running or not. Standard mode is no reconciliation happening. At ACR mode means you are reconciling your data at the monitor. If you select ACR mode, then of course we need to put in an unstable delivery timer, which is the amount of time we're going to give the tank to settle down after a delivery. Do we have a vapor recovery system installed? Simply yes or no. We have stage 1 or stage 2, or we have both. The evaporation factor is a number that we could get from our fuel supplier as well, and it has to do with how much product will evaporate in how much time based on temperature. This is the difference in winter and summer blend fuels. DMS, are we going to install, back up again, See, I'll tell you back up again. Yeah. DMS, we would check this box if we were going to install a density measuring sensor on this tank, and the density measuring sensors measures the density of the product instead of waiting for a separation of the ethanol or water in the bottom of the tank. If we select this, then we are able to put in a factor A and a factor B and a tolerance. The factor A and the factor B are numbers that are actually stamped on the side of the DMS sensor, and you would use those numbers in those fields. Are we going to do timed leak test automatically or do manual test? And that is between you and your customer. Automatic means we would simply try and find an opportunity to do a static test. Manual means just that. We will do testing, but we will come out there and start it manually and end it. Minimum product level that we would want in the tank to do that test. We could program this at 50% is kind of the number that we are hearing from many municipalities across the country. We simply click apply on this, and we now have tank 3 available to assign a probe to. And once that's finished, if we go up to tank number and hit our drop down, you can see now we have tanks 1, 2, and 3. If we look at tank 1, for instance, we can see that the serial number off of the probe is displayed, the product type, what kind of tank it is, the color of the tank, and all of those things that we just programmed on our tank 3 are already there. If we look at tank 3, however, you can see that we do not have a serial number yet. That just simply means that there has not been a probe attached to that tank. Sensor configuration. Now in sensor configuration, just like in tank configuration, this is simply where we go install the sensors that are on the unit. Just like with the tank, we can configure a new sensor even before it is installed by simply clicking the box that says configure new sensor, and it tells us no sensors are available to configure. What we're going to do is I'm going to click OK on this and then uncheck this box because it's pretty self-explanatory, and as we look at the sensors that are there, we can understand how they would get programmed in. So we'll uncheck that box, and if I look at sensor number 1, for instance, it has the serial number listed for sensor number 1. It has the description that we have typed in. It's a regular annular space sensor. It tells us what position in the IS module it is installed, and it is on channel 2. Remember, we have 4 channels available. The sensor type, it is a liquid-only float sensor, brass, and the model number, and then of course we have our little icon that is a picture of the OPW brass sensor. Now we can associate this sensor with just the site in general, which means we're going to use the description to sort out where each sensor is. We could say that this sensor is a sump sensor, or it's under a dispenser, and if it's under a dispenser, what dispenser number is it under? Or it is associated with a tank. And this one just happens to be the annular space in the regular tank, which is tank number 1, and it says it's regular. The current sensor status, it is a reading associated with whether the sensor is in alarm or not, and 0 is a good number for that brass sensor. Down at the bottom we have our sensor alarm actions. What do we want to happen if this sensor goes into alarm? Do we want to sound a buzzer? That's the audible. Do we want to print when the event starts? Do we want to print when the event ends? Do we want to close one of our internal outputs? We may close output number 1, which goes to some type of alarm light or horn that notifies station personnel that that sensor is in alarm. Do we wish to send out any alarm notifications? You may want to send an email out to Lewis guy because he is the compliance person for this company. So if this sensor goes into alarm, Lewis is going to get an email. So let's apply this. Once again, no apply, no work. As you can see, we actually have 3 sensors installed. And if we look at just sensor number 3, just for grins, sensor number 3, serial number 2539, and we can see that it's installed in a regular STP sump. It's also attached to IS barrier position number 3 in the Nano. It's a discriminating dispenser sump sensor. And there's the sensor model number. And by being discriminating, that means it can distinguish between just a liquid or a hydrocarbon liquid, gas or oil or diesel. We could change the association for it as well, and notice the levels on it are a little different than the brass sensor was. That is simply because this sensor works on a different principle than just a float switch. We have checked that it's going to, if this sensor goes into an alarm state, we're going to sound an audible alarm, but as it is set right now, we're not sending out any emails or closing any outputs. Once again, you would have to hit apply. No apply means no work. If we wanted to just get rid of this sensor, say for whatever reason it was removed from service, we simply select this sensor and click the delete button, and it would remove it off of the system electronically. Our tank thresholds. Once we have our tank configured, our sensors configured, then we start looking at our thresholds. Now, the thresholds are just the times when alarms are going to be active. So if we look at tank 1, that's our regular tank. We see our name and the product name and our safe working capacity, 95% of a 2,000 gallon tank. Right? These check boxes here tell us that these alarm conditions are active alarm conditions. If you had a location that for whatever reason never wanted to get a product low alarm, you simply uncheck that box, and once you apply those settings, that regular tank would never generate a product low alarm. Most places, of course, are going to have their product low alarm active. The next line over simply tells us whether we want this number in inches or height or volumes. So we can see that 45.6 inches, if we select the volume button, that is 1,962.61 gallons. The delivery start threshold is 26.41 gallons. That's factory default. Once we see an increase in the tank volume at a rate of 26.41 gallons a minute or greater, we will know that a delivery has started, and we will keep that delivery active until the increase in the tank drops below whatever the delivery in threshold is set at, and the Nano defaults at 26.41 as well. Once the flow rate drops below that, we would consider that to be the end of a delivery. Standard theft detection defaults to 0 gallons. The theft detection does not start until the Nano site is closed. Once the site is closed, if any product over this limit leaves the tank, we are going to sound a theft alarm and print a report if we have a printer attached. High temperatures and low temperatures. These are generally reserved for times when, in really cold climates, when we may need to kick on a heater or something to stop diesel fuel from gelling, or we have a DEF tank in a very cold climate and we want to make sure to turn the heaters on before it has an opportunity to freeze. And the same thing on the high temperature, just a high temperature limit that we would want to set. So we click apply on that. We move on to our tank strapping table. In the strapping table, once we select our tank, and let's just select tank 1, which of course is our regular tank, and we'll leave it on tank chart. We could export this as either a CSV file or text, and we have a starting point of 0 inches and a stopping point of 48 inches, which is our whole tank. If we click show points, then it will show us what the tank monitor is reading as our product volume based on height every 2 inches all the way up the tank from 0 to 48 inches. We can change this. We could make it read every 1 inch. And it would do the same thing, only every 1 inch instead of every 2 inches. And the other option that we have available is the strapping table. And if we wanted to see what the strapping table was, we don't have anything right now because the strapping table is actually built off of ACR data. If you will remember, when we were back on tank configuration, we told it whether or not we were using an ACR configuration or a standard mode. So standard mode versus ACR. If we were in ACR under tank strapping table, we could look at the strapping table and see what the ACR had built for a tank chart for the selected tank. The tank correction table is where we can actually put in correction points in the tank chart. For instance, if we want to go ahead and tell it according to the tank chart that we received, we looked on the tank chart and noted that at 24 inches, instead of being exactly 1,000 gallons, it was 998 gallons. And we simply click add. It asks us to verify that we just entered 24 inches with a volume of 998. Are you sure? And we say okay. And what that did was that just made an adjustment to the tank chart and said, regardless of what you thought 24 inches was, I just told you 24 inches is 998 gallons. And it would work off of that number instead. Alarm actions. When we get to the alarm actions button, this is the alarms that we can have on our tanks. And what do we want to happen when each of these alarms is active? Before you can set up your alarm actions, you need to make sure you select the tank number that you want to use those on. We have our product high, product high, product low, low, water high and high, probe failures, high temperatures. So remember we were talking about temperatures. If we needed to turn on a heater, if the product got too cold under low temperature, we could close an output that would turn on the heater. Right on down the list, failed thermistors, delivery start and finish. If you want to print a report at the end of every delivery, then we must go over here and click end, print on event end for a delivery start finish. If you don't do that, we will not print a report when the delivery is over. And then of course our tank test warnings and theft warnings and things that we would like to have happen there. Most places we're going to sound audible alarms on all of those at the very least, and potentially print on them as well. Now, if you print on product high or high, if you check print on event start and end, it will print when the event first happens, and then when the event clears itself, it will print again. Most people would not care much for that because it burns up the paper. Of course, the same thing happens on the internal outputs. If the unit has an OM4 connected, this is where we would select OM4 to tell it how the relays on it are going to work. Once again, we have to apply. Okay, once we have completed our alarm actions, it's time to move on to reconciliation. Now, under the reconciliation button, this is where we are actually going to set up how our automatic reconciliation between what is sold at the dispensers and what is delivered and pumped out of the tanks matches up. At this point, we are actually listening to the dispensers via an interface to know which dispensers are selling which product and how much product has been sold. Then at the end of the day or the hour or the month, we compare what was sold to what is in the tank and issue a report based on that information. The first part of reconciliation is the auto calibration process. And to get it started, of course, we have to select the tank number that we want to start auto calibration on, and when you hit our drop down, I notice the only tank I have is tank 3, which is the tank that doesn't have a probe in it yet. So we need to go back to our tank configuration. Let's just select tank 1. Remember when we were here on the ACR configuration, we left it at standard mode. Let's change that to ACR mode and just hit apply. So now when we go back to reconciliation again and select auto calibration, then we can get tank 1 as well. And as we're looking at tank 1, it will tell us it's the tank is called regular and the product that's in it is regular. The status and remaining times, this is the auto calibration time in a percentage value as to when it starts and when it stops. And of course, it hasn't started yet, so we're 0% complete. To calibrate, one of the things that we have to actually tell it is our start and stop volume levels. For instance, if you had a customer who never let their tank get below, let's say, 500 gallons, but they never filled the tank up beyond 1,500 gallons, if we put those totals in there as a from and a to volume, then we will only be interested in calibrating the tank between the 500 gallon mark and the 1,500 gallon mark. And we would ignore the rest of the tank at that point. Now, in our calibration cycles, what is required is a minimum of 3 cycles and a maximum of 5. So we could bump this up to 3, 4, or 5, and it would still work. But what this is going to require is that we would be expecting to see the tank between 500 gallons and 1,500 gallons 3 times. And we're talking about starting at 1,500 gallons and going down to 500 and then starting that again at least 3 times in order to be able to calculate what the actual tank chart would be for that area of the tank. An unaccounted variance period is just as it says. It is a period of time that we are going to have set aside to allow for an unaccounted variance. This period of time can be anywhere from 0 hours up to 24 hours per day. Once we have all of those settings completed, we come over to our state and we would enable it. Once it is enabled, we would make sure that it started and everything should be grayed out. If everything is running as it should, these buttons are grayed out, and at this point we are running ACR on tank 1. Once you have completed the auto calibration settings, the next thing to select would be hose mapping. And with hose mapping, we are actually telling the unit which pump number and which hose off of that pump is associated with which tank. So for this exercise, we're going to say that we're dealing with pump number 1, and that is pump 1 on the island. The hose that we're dealing with, because we have a multi-hose dispenser, it's going to be hose number 1. And the tank that we have associated it with is going to be tank 1, which it tells us is regular. So we have said that pump 1, hose 1 is regular. Now the offset is an amount of variance in the meter calibration off of 0. So if we know that there is an offset on the meter, we can put this amount in there so that it would be correctly figured and calculated in our reconciliation numbers. Now you can't leave this field blank, so if you have a meter that is set on 0 with your calibration can, you would simply select a 0 in this field, and we would click add at this point, and it adds that pump 1, hose 1 is regular. So we could add, let's go back to pump 1 again and hose 2, and select tank 3, and it says it's premium with a 0 offset, and we add again, and we now have pump 1, hose 1 is regular and hose 2 is premium. And you would do that for all of the pumps and all of the hoses at the site. And once that is finished, hose mapping is done and reconciliation can start running. Let's show a mid-grade, a blended product, because we have regular and premium there. So on hose 1, let's say that hose number 3 is actually our blended product. And the first tank that we come out of with that is our regular tank, of course, with no offset on it. The second tank we would come out of would be our premium tank with no offset on it. And we simply tell it what our blend ratio is. A blend ratio which is, in this example, a 65-35 blend between regular and premium. And once again, we would just click add. And now we can see we have a 3-hose MPD, that is pump 1, hose 1 being regular, hose 2 being premium, and hose 3 being a regular premium 65-35 blend. The next button we click is the thresholds button, and this is where we're going to sound alarms and such. So let's select tank 1. Now our test VIN, this is an amount that we would put in that would equal what a normal test can would be, so that if the system sees 5 gallons dispensed on pump number 1 regular and then immediately sees 5 gallons poured back into the regular tank, we will calculate that 5 gallons out and 5 gallons in must have been a test VIN. The loss warning is a number of gallons per hour that we could see that are gallons leaving the tank that are unaccounted for before we would sound a warning. Loss alarm is the same thing, the number of gallons per hour that we could see leave the tank unaccounted for before we would signal a loss alarm. And remember, there is a difference in warnings and alarms. Warnings are going to be yellow light flashing, alarms are going to be red lights flashing, and you can have different things happen for different alarm types. The unaccounted is a total number of gallons during a reconciliation period of time that if we lose this many gallons, we're going to sound an unaccounted alarm. The daily unaccounted alarm is similar, except that it can be displayed or calculated by percentage or by volume, whichever one you would want, for an unaccounted volume that you could lose in a day's period of time before you sound an alarm. The unexpected sales section is a place where we can put an amount of product that we would allow to leave the tank before generating an alarm. So the monitor would be watching the tank, and if it sees no dispensing happening, but this amount of product leave the tank during a specific time period that the monitor will decide, it would trigger an unexpected sale reconciliation alarm. The next thing to look at after we have set up our reconciliation is the Reports tab. Now in the Reports tab, this is simply something that we put in here to access via the web browser so that there were some things that a technician or someone from a remote connection could access without having to use a VNC connection. All of the reports here are printable except for the current inventory. So if we look at the current inventory, what it will actually show us is the current inventory of the tanks that we have and probes installed. Now you notice the tank 3 there, that's that tank that we programmed a while ago that I do not have a probe for yet. And if you'll notice, there's nothing on here to indicate that we could print this. It's just a real quick thing where you could just go look and see exactly where your limits and levels were. The rest of the reports, as I mentioned, are printable. So if we look at the delivery history report and we select a tank, we can see that tank 1 has had a delivery and it has all of the pertinent data for that delivery. We have a little bit of a scroll across, tells us the state of the tank. There's our times, reference temperatures, volumes, and with the icon, if we have a printer attached, we click this icon and it would print this report out to the printer attached to the unit. And of course we can select which tank that we want the report for. The events in progress, if we had some alarms that were actually current right now and in progress, it would show us those alarms in this field and we could print that out once again on the local printer. The events history, just as it sounds, it is a history of events for the site broken down by time and date and tank sensor or system. Leak test. If we have leak test active or completed, this is where we can go and print a leak test report. Measured leak rate, the duration, volumes, end date and time, start date and time. And once again, we can print this report out. It would actually list them by tank number, test type, all the way across the board. Now these reports, the hourly, daily, and petroleum report, are actually our reconciliation reports. The hourly report shows us, once we select our tank, it shows every hour for the last 24 hours what the status of our tank was from a reconciliation standpoint. And you can see whether we had a loss rate during that hour, the date and time, volume of the tank, temperature, any sales that happened, any temperature variances, any evaporation variances, any water variances. And you can do those per tank and it will show, as I said, every hour for the last 24 hours. Then we have the next report is a daily report. The daily report displays the daily status for each tank. Instead of just each individual hour, it would display just the whole day. If we select the tank on it, yeah, we can see that we have not been running long enough to compile a daily report yet. The petroleum report will report a total of days based on a start date and an end date that you put in per tank. So we could have a start date of today and an end date of the 31st, which would theoretically be a petroleum report for all of March for tank number 1. and click apply, and it would show us a total of all of these parameters that we use to do a reconciliation report. Once we've finished looking at our reports now, so let's go down and see what we have in Diagnostics. Now, Diagnostics, as the name would indicate, is something that we as a technician may use to troubleshoot the system. If we look at Probe Diagnostics, this is a diagnostics tool that we would use on a pretty regular basis, especially if we thought we were having some probe issues. Now, we do need to know the serial number for whichever probe we want to view diagnostics for. And once we make that selection, we can see several things about that probe. The velocity, and that is basically a speed factor on how long it takes a signal to get down the magnetostrictive wire in the probe, the software version and the probe type, the probe height, 20 inch, that's a big probe, isn't it? The rough product height and the fine product height, and the water height. Now, if we had a density sensor installed, we could see that information in this box. The probe temperature, this is how we are reading each of the thermistors. This is a place where we may look, especially if we were having trouble passing tank test, because what you may see is thermistor 1, 2, and 3 being, like it shows here, 75 degrees, and all of a sudden thermistor 4 is negative 41 degrees, and then thermistor 5 is back up to 75 degrees, and thermistor 6, which is actually in the head of the unit, maybe 85 or even 90 degrees. That one thermistor being way out of kilter with the rest of them is an indication that there are some things in the probe itself failing, and that can cause us to be very unstable when we are testing the tank. So this probe temperature and seeing the thermistors and the number of thermistors is a very important diagnostics tool. This probe, as an example, only has 4 thermistors in it. Most of our probes have 6 thermistors in it. We have 5 in the probe shaft itself and 1 in the probe head. But this one, since it is only 20 inches long, they did not have enough room to fit any more thermistors in there. It's just a test probe. We use it for training and demos, so that's why it is basically non-applicable on thermistor 4 and 5. Right. The good data received, good product reading, good water reading, good temperature readings. This counter over here should always be 0. If we start seeing this counter go up, then we are having some type of difficulty with the probe. Now, that could be a connection issue as well as a failing probe issue. Just good information available in probe diagnostics. Then we have a log file. Now, the log file is exactly as it says. It is a log file of what is going on in the unit. Now, what we can do, we don't run the logs all the time, but if we enable the logs, and you may be asked at some time by tech support or someone to enable logs on a unit you're having trouble with, if we click enable the logs, we start collecting data and processing it out to a log file. Now, that log file is going to be written to the SD card. So it's explained in the manual on how we can pull that log file off of that SD card and get it on our computer so that we may be able to email that to tech support or myself or someone else at OPW who may be needing that information. So we enable it and it starts collecting data. We let it run for how long we have been asked to let it run, and then we disable it. And once it is disabled, that is when we can go out to the SD card and transfer that file from the card onto our computer. The barrier diagnostics we covered just a few minutes ago when we were before we did our site setup. We'll look at it once again just so you can be refreshed. This is the voltage going to our channels on the barrier, whether we have power to the unit or not, and the potentiometer. One thing that we do have that happens on the barrier on the Nano, if a wire gets shorted from the barrier, the Nano will turn the power off to all channels on the barrier for 5 minutes. After that 5 minutes is completed, it will then turn the power back onto the barrier, and if the shorted event is gone, then the barrier will start working as it normally would. So we don't completely burn out a channel on the Nano if we have a shorted wire on the barrier. That concludes this demonstration of how to set up the Nano monitor via a web interface. Remember, according to your manual, you must do this programming through the web interface. It is not available through the touchscreen or the VNC viewer. Thanks for watching and have a good day.